There's a story that tends to get told a lot about great white sharks, and it goes like this. Killer whales show up, sharks hear them, sharks panic, sharks flee. It's a relatively simple and easy timeline that's packed full of drama, but it's not quite what the science actually says. Because when you look closely at the research, the tracking studies, the acoustic experiments, and the sensory biology reviews, what you find is something much more interesting and far less simple. Great white sharks don't just hear an orca and scarper. They assess, they integrate the information, and sometimes they might not even react at all. So join me today as we myth bust this popular claim in shark science, and instead we'll ask a much better question. How do great white sharks really detect orcas? Under what conditions does that detection actually change their behaviour? And can we harness this process for use in human-worn shark deterrents? Anyway, welcome back to another Shark Bites episode, everyone. Now, first I want to clear something up. Sharks aren't afraid in the way that people imagine. Sharks don't panic. They don't have emotional narratives running through their heads. That right there is anthropomorphism, man. We definitely don't do anthropomorphism here on the channel. What sharks do have is the ability to perform sensory processing and, importantly here, risk assessment. We know that killer whales do kill sharks. Both white sharks and plenty of other shark species are on the menu for these black and white psychos, but when they do, the cost to that shark is more often than not total. There doesn't tend to be any minor injuries that can be recovered from when a shark ends up in the sightlines of an orca. There's really no escape if they make a mistake. And so because of this, natural selection will strongly favour the sharks that respond early and accurately to reliable cues that killer whales are nearby. Keyword there being reliable. Now, let's get vision out the way, because I would say that this one is probably the least controversial part. Great white sharks, contrary to popular belief, actually have relatively good eyesight, but despite that, they're not visually detecting orcas at distance. Light drops off really quickly underwater, and visibility changes constantly. You can go from 50 meters plus of horizontal viz at the start of the day to an absolute murk fest within the space of a few hours. Killer whales also don't need to be at the surface constantly for them to be present in an area, and sharks don't need to be in the shallows for the killer whales to hunt them. So if vision were the primary detection system, then you'd say that sharks maybe were reacting a bit too late, but based on the evidence that we have, they aren't. Which means that whatever is happening here is happening long before the killer whales are visible to the sharks. Now that, I'd say, brings us quite nicely onto our first real sensory factor that's involved. Sound. Sound dominates the ocean, and the ocean is a noisy place. You only have to pop your head under the water near a coral reef, and you'll be instantly met with a cacophony of crackles and pops, demonstrating an underwater world teeming with activity. Low-frequency sound travels far underwater, and to hear those sounds, you don't have to have a line of sight. They can bend around obstacles and are absorbed less into the surrounding water. Sharks as an animal are particularly sensitive to these low-frequency sounds and can detect particle motion through their inner ear as well as their lateral line. And this makes them especially tuned in to the kind of signals produced by large animals, particularly killer whales. Killer whale calls consist of both low and high frequency components, but generally can be characterized by a broad range of sounds adapted for different purposes. For example, the socializing whistles that we probably commonly associate with killer whales are used in close range communication, and these ones range from 0.5 to 40 kilohertz. But some of their pulsed calls come in at anywhere from 50 hertz to 5 kilohertz. So you can see they've got this broad range of frequencies, and sharks will absolutely be able to detect the ones that are coming in at that lower range. And that information right there, by the way, isn't speculative. A classic OG shark science research paper that came out in 1978 featuring the renowned Dr. Peter Klimley literally describes the rapid withdrawal from a sound source by open ocean sharks. And that phrase isn't an interpretation. As you can see, it's the title. In that study, sharks didn't need to see or smell anything. Certain sounds alone were enough to make them leave. Follow-up work published a year later refined this a little bit further, deciphering that not all sounds triggered avoidance behaviour in sharks. The response itself depended on frequency, amplitude, and temporal structure. In other words, the sharks in those studies weren't just simply reacting to noise, they were reacting to specific acoustic patterns. Now, if we fast forward to modern day shark research, there's a study that often gets cited as evidence here, but in a few cases, I think people maybe have oversimplified it a little bit. In 2019, sensory ecologist and marine bioacoustician Dr. Lucille Chapuis published a study where her and her team tested shark responses to underwater sounds, including killer whale vocalizations. Within that study, they found that 7 different species of reef and coastal sharks living around Exmouth in Western Australia responded to orca vocalizations by being less inquisitive or reducing their approaches to the bait. Essentially, they were deterred by that noise, but here's the part of the study that sometimes gets ignored. When they performed the same experiment with white sharks, the white shark behavior didn't significantly change in response to the killer whale calls used in that experiment. Nada, zero. though, no statistical effect. They weren't deterred. Although this is where it starts to get a bit interesting. The killer whale vocalizations used by Lucille and her team were recorded from Australian orcas, while the white sharks they tested it on were from South Africa. Orca vocalizations aren't acoustically universal. Different populations have different call repertoires that are shaped by social learning within the pod and varying hunting strategies. So from the perspective of those South African white sharks, the noise that they were hearing might not have sounded like a threat at all. It's kind of like if you went to China, right, and you don't speak Mandarin or Cantonese, and a guy comes up to you speaking one of those languages saying, hey, look, in a couple of minutes there's a gang coming, you might want to get out of here, but you don't understand him because you don't speak the language, so you don't leave. It's kind of a simple explanation, I guess, but you get what I'm saying. So Lucille's study here wasn't showing that great white sharks ignore orca sounds. Instead, it's suggesting that sharks might only respond strongly to locally relevant acoustic cues, sounds that match what their nervous system has learnt to associate with danger. And I'd say that's pretty strongly evidenced by the fact that the 7 coastal and reef sharks found in Australia all freaked out when they heard the Australian killer whale noise. But it's probably also evidenced by different locations around the world where you get a spatial overlap between orca and sharks, but no obvious signs of a predator-prey relationship going on. For example, in places like New England and Cape Cod, where seasonally you've got white sharks, but also you've got orcas showing up every now and again, those sharks there don't flee, or at least don't evacuate as dramatically as they do in other parts of the world. And so perhaps it's because there's no apparent risk of predation, and the sharks there don't associate those orca calls with danger. So we're not talking about a simple reflex here, or a generic orca alarm. We're talking about selective perception, which is super cool. It would suggest that sharks aren't keying in on orca calls as a distinct category, but instead respond to combinations of frequency, rhythm, repetition, and movement that are all suggesting a large, coordinated predator is nearby. If the sound they're hearing doesn't match the internal template the sharks have got, then that might not trigger an avoidance behaviour, even if the sound technically came from an orca. Personally, I'd say that actually makes this shark behaviour more impressive, not less, because they're not overreacting to every unfamiliar noise in the ocean. Now, we could say that sound is providing the context for the sharks, but some of their other senses are likely providing the confirmation. For example, the lateral line, which we briefly mentioned, could definitely be detecting some of the water vibrations and signals coming from a large animal like a killer whale. But an even bigger detector that these animals have got is smell. I think shark smell, or more scientifically their olfaction, is sometimes a little bit misunderstood here. In popular media, sharks are pretty famous for being able to detect or smell blood, but olfaction isn't just about feeding, it's about context and history. When a shark is injured or even killed, chemical compounds are released into the water, and these are often referred to as necromones, aka chemicals associated with injury or death. And again, we're not talking hypothetically here. Back in 2014, research showed that sharks exposed to necromone cues from injured members of their own species ended up reducing their activity levels and tended to avoid the area. They didn't rush in to investigate driven by some bloodthirsty need to feed, they altered their behaviour in a way that was consistent with risk avoidance. More recently, in 2021, Dr. Connor Gervais showed that necromone exposure in juvenile Port Jackson sharks led to measurable changes in their oxygen uptake, which reinforces this idea that these chemical cues function as some kind of environmental warning signal. So in places like South Africa, where you've got orcas killing sharks and selectively removing their liver, the surrounding water doesn't just contain blood, it's packed full of sensory information. Sharks passing through at a later point might not be detecting those killer whales, but they're detecting the evidence that something lethal happened there before to one of their own. So it's probably a good idea to get the heck out of Dodge. And I think that evidence there helps us explain long-term abandonment of entire areas or habitats way better than just sound as a factor on its own. Okay, so here's the myth-busting conclusion that we've got going on. Great white sharks, or any shark for that matter, don't just have a single orca detector. They're integrating multiple sensory inputs over time. Sound might provide an early clue, but only if it's meaningful sound. Water pressure changes via that lateral line confirms the proximity of the threat, and then chemical cues encode memory of past events and initiate that risk assessment. And finally, vision, you'd say, could play a minor late-stage role, but by the point where vision is involved, I reckon it's too late. And then critically here, not every orca sound triggers a dramatic response in sharks, and that's not a flaw in the shark's biology. I think that that's evidence these sharks can discriminate between threats and non-threats. So if you were to put this in the context of maybe trying to use it in human worn shark deterrents, you can see it's not as easy as it might seem, because suddenly you've got to pack a bunch of things into that device, like the ability to produce those low frequency orca calls or some kind of manufactured shark necromone that's being slowly released into the water. But even with all those things, someone could be wearing a device in a location where the sharks might not respond to it because they don't perceive those signals to be threatening. Besides, even if we did manage to create a hypothetical device here that had all of those things and it worked, we've not even considered here what the long-term ecological impacts of hundreds of surfers and swimmers wearing these things could do to the environment. So you can see then it's definitely not as clear-cut and easy to replicate as it initially might seem. Going back then and looking at this from a predator-prey relationship, killer whales don't dominate sharks because sharks are weak. They dominate them because many sharks are clued up enough to leave. The science that we've looked at today doesn't support a narrative of panic and fear. What we've seen has shown us that this comes down way more to selective attention, sensory integration, and evolutionary pressure that favors a species that is more cautious than confrontational. The ocean isn't dictated by the loudest signal that you can hear. It's dictated by the signals that mean something, and white sharks are generally pretty good at telling the difference. Looking at these two predators, I'd say there's no better example of this evidence than in South Africa, and for many years we've been led to believe that two killer whales here have essentially deleted the entire population of white sharks. But in this video here, I show you that maybe the story we've been told is only a tiny fragment of what's really going on. So if you want to learn the main reason as to why white sharks basically vanished from South Africa, make sure you give this video a click.